Good morning, everyone. आवाज आ रही है. So welcome to you all on Exampur IAS English Medium. And today we are going to discuss ocean current. Earlier we have started the oceanography topic in which we have finished the ocean relief. Okay. Okay, two more slides I want to show you for ocean relief. Okay, first of all, and then we will go for the ocean current. So here you can see the trenches in Pacific Ocean. This one is the Aleutian Trench. You can see here is the Kurile Trench, Japan Trench, Rikuku Trench. So these are the smaller trenches which can be asked in a UPSC Prelims. So you should must write down these trenches also, which is present in Pacific Ocean. Okay. One more I am going to tell you about the ridge of Indian Ocean also. So here it is the Philippine Trench and the Java Trench is there. Okay, of the Indian Ocean. And then you can see the Mariana Trench is there, Bougainville Trench, and Tonga Trench is there. In last class we have written a Tonga Trench. Okay, Karma-Deck Trench is there, Karma-Deck Trench. Okay, and then the Peru-Chile trenches are there. Okay, so these are the trenches, and also the Puerto Rico Trench of the Atlantic Ocean, which is the deepest of the Atlantic. So deepest of the Atlantic is the Puerto Rico, deepest of the Pacific is the Mariana or the Earth or the world, or deepest of the Indian Ocean trench is the Diamantina Trench. Okay, Diamantina Trench, which is found here. Diamantina Trench is here. Here it is the Diamantina. Next, in next slide you can see. Here it is the Diamantina Trench. Okay, here it is the Diamantina Trench. Now you can see there is a Sunda or a Java Trench because it is nearby to the Java. So it is also referred as a Java Trench. And here it is the in a S shape. You can see the mid-Atlantic ridge. This one is the we are talking on the Indian Ocean. Then there is a Lagos, Chagos, Lakshadweep ridge, or Lakadweep Chagos ridge we used to say. Lakadweep Chagos ridge it is. And then the southern side of this ridge, you can see the Reunion hot spot is there. Reunion hot spot is there. So the deepest point of the Indian Ocean would be Diamantina Trench, having a depth of 8,047 meters. So this one is about the Indian Ocean, and here it is. You can see about the Pacific Ocean and the Atlantic Ocean we have seen. Okay. So now we are going to attempt oceanic currents. So next one is ocean currents. So next topic is ocean current. Or a movement of water in oceanic region. Okay, movement of water in oceanic region. What do you think about the current or a jaldhara in Hindi? So firstly, the actual transportation of water from one place to another place, that would be called the current. Like in a winds, we have seen when a air acquires the motion and having a direction, it is called the winds. So like in oceanic region, you can see when the actual transportation of water happening from one place to another place, it would be called what? It would be called a ocean current. Okay, it would be called what? The ocean current. Is it clear, Mradul? Then let's have some sentences for the ocean movements. You can see here the movements that occurs in oceans are categorized as waves, tides, and the currents. What do you know about the waves and the currents and the tides? Tides happen just because of the attraction force of the sun and the moon in the coastal region. But how the waves and currents occurs? So I am giving an example. Like see, this is a coastal areas. It is the ocean. Now you can see it is the ocean, and current is moving towards this coastal region. So whenever it is coming towards the coastal region, the depth becomes low or it is becomes a shallow region. So when it becomes in a shallow region zone, you see it will break down. Okay, and then it will move like this from the beneath of that place. Now it is broken into this region, and these regions are called what? A plunge area. These areas are plunge area or a surfing area. Surfing area where the currents has broken. Okay, you can see the currents has broken in this region. Okay, currents has broken in this region, and the one part is moving just above the oceanic region or ocean plains, and the another part is from this way. You can see the waves. This is called the waves. Here it is the waves, or it is the swash. So these are the swash, and here it is the backwash. This one is backwash. Okay, so currents has broken in the plunge area or a surfing area, and the one part which is going towards the coastal areas, that is so called the waves or a swash. Another part which is going towards the abyssal plains region, that is so called the backwash current. So these are the backwash current, and these are the swash and the waves. So you can see, if you are standing on the beach region, you feel the waves, not the currents. So you are seeing only the waves, not the currents, because the currents has already broken in plunge area or a surfing area. Getting it or not, Mradul? So that is all about the waves, and we will discuss tides later on. What is tides, how the tide and ebb occurs. Okay. Then waves are formed due to the friction between wind and surface water layer. Here you can see wind and surface water layer. The stronger the wind, the bigger the wave. They die out quickly on reaching the shore or shallow waters. What I said, when it reaches to the shallow water region, it is quickly going to die. Horizontal currents arise mainly due to the friction between winds and the water. Like you see, here we are showing the waves. So here at this place, the current has broken. Then how it moves? It moves because of the friction with the winds. So here you have to mention friction occurs by winds. Okay. So stronger the winds, stronger the waves. So you can feel it in the coastal areas or beach areas. Whenever you will go to visit the Juhu beach or a Puri beach or a Goa beach, okay, you can feel it. So next, and also horizontal currents are mainly due to the friction between the winds and the water. Now, one more point. Coriolis force and differences in water level gradient also play a major role. One more point about the waves. Coriolis force and differences in water level. Somewhere you can see the water level is higher, somewhere in the lower. So also it will play a major role. Then vertical currents arise mainly due to density differences caused by temperature and salinity changes. We are coming to this part. And the tsunami, the storm surge, and the tides are tidal waves, meaning waves with large wavelengths. So these are also the waves. You can see the tidal waves, the tsunami, which occurs on the coastal areas of the Japan, where the meaning of the tsunami is su, that means the harbor city or a port city, and the waves, that is the nami. Combined, it is called the tsunami. Okay, combined is called the tsunami. I'm getting your comments on my screen. Okay, then let's see the next point, how the ocean currents originates. Now we are going for origin of ocean currents. Origin of ocean current. How it happens? So there are two primarily forces which affects the origin of currents. I'm dealing it, just have some facts. So ocean currents are influenced by two types of forces, namely primary forces that initiate the movement of water and the secondary forces that influence the currents to flow. The first one, which will generate the movement of water, and the second force will influence the currents to flow. The primary forces that influence the currents are, what are the primary forces which influences the currents for the movement of water? That is the heating by solar energy, the winds, gravity, and the Coriolis force. So these are the forces. I'm talking about the forces, and now I'm going to explain how the currents originates. How? And the questions, how the questions arises in a UPSC IAS. Coriolis force I am just explaining, Mradul. Wait for 2 minutes. And then what about the secondary forces? So the secondary forces that influence the currents are temperature difference and the salinity difference. Both will create the density differences. These two will create the density differences. So come to the point. So firstly, we are going to get the how the currents originate. So first, here it is the oceanic region. Now you see, this one is the oceanic water, someplace. You can see it here. Now, at two different places, like these are two different places having a different temperature. So, at some places, you can see the direct rays of the sun is just over the Earth's surface, and somewhere it is in a slant rays. So now you see, here it is the direct rays of the sun, or equatorial zone is this. These are the equatorial zone. So here you can see the temperature is high, and because of temperature is high, there would be low pressure firstly. The air rises above. Okay. And then the temperature is high. So at this place, the rainfall is also high in equatorial zone. Then you see, when the rainfall is maximum in that region, it will low down the salinity. So the salinity is low is at this side. Salinity becomes low. And when the salinity becomes low, it will low down the density. So now the density is low also. So now you can see the density is low. Because of the less salinity, the sea level will rises here. Above. At this side, sea level is rises. Because of the air is moving upwards and it has created the low pressure. So the sea level rises. Sea level increases at this junction. Now at the second side or another side, you can see the temperature is relatively low. And so it will create the high pressure at this zone. Here it is the low pressure, it is the high pressure. Then you see at this side, the temperature is low, pressure is high, and because of the less rainfall, salinity becomes high. Vaporization is high at this place also. So salinity becomes high and it will create a density increases also. A density is also high or increases. So when the density increases, the water becomes heavier and it will go down. Now you see like this. So it will create the low sea level. Now here you see low sea level. So at some places there is high sea level and other side there is low sea level. And these variations of the sea level tends to move the water from one place to another place, and that is an actual transportation of water from one place to another place. Getting a point? It will creates the movements of water from one place to another place, and the actual transportation of water, that is so called the current. So now you see here the current is moving. Here it is the current, and it's having a speed and direction both. So now you see the current having a speed and direction both, but the speed is low. Speed is low just because it cannot varies the maximum gap or a gradient. So now you see the current is moving from one place to another place, and the actual transportation of water from one place to another place. ये लिख के रख सकते हैं. Right? Actual transportation of water from one place to another place. Okay. Getting a knot, Mradul Raj? Because this is English medium classes, so I am trying my best to explain the whole content in English only. Okay. For Hindi, we have separate channel. That's the IAS PCS by Exampur. There you can see the whole content is providing in a Hindi. So if you are a Hindi medium, then you can join the separate channel, that is the IAS PCS by Exampur. Or if you are from English medium, then you can join us at this channel, or must support this channel. We will do rock at this channel also. So Mradul has asked the Coriolis force. I am coming for that, brother. Is it clear? Firstly, the differences of oceanic water about the temperature, salinity and density creates the ocean currents. If you want to write down the definitions of ocean currents, you must write down, brother. So firstly, you must write down that's the oceanic currents formed or originated by differences of oceanic temperature. ऐसा भी कर सकते हैं. Oceanic currents are formed or originated by differences of temperature, salinity and density of oceanic water. Temperature, salinity and density of oceanic water, along with it is also affected by rotation of the earth, prevailing winds and the shape of coastal line. Here we are discussing again the one more point about the Coriolis force, which I have already explained in the wind section. Mradul, you missed that class. Okay. So, okay, one more time I am going to explain about the definition. So, ocean currents formed by differences of temperature, salinity and density of oceanic water, and also it affected by prevailing winds, rotation of the earth and shape of coastal line. So now we have discussed about how the differences of temperature, salinity and density of oceanic water creates the current. Second one, we are going to discuss how the rotation of the earth generates the currents. So you can see here, earth rotates from west to east. Earth rotates from west to east, and just because of rotating on its axis of the earth, it will create it implies a deflection force against it. This one is deflection force. Deflection force which originates by the rotation of the earth. Which originates by the rotation of the earth. Rotation of the earth, and it applies against the direction of the rotation of the earth. So now you see it implies from east to west, and this is the deflection force. It was discovered by the Coriolis of person. So this one is called the Coriolis force. So deflection force is the Coriolis force which was discovered by the Coriolis. That's why the name given a Coriolis force. Aman Kumar, are you getting, brother? So if the earth rotates from west to east, now you see at this juncture, here it is the 0-degree equator line. And at this side, the rotating speed of the earth is maximum. Rotating speed is maximum at this place. So when the solid part is moved ahead, the liquid part will left behind. And now you see there is a movement of oceanic water from east to west. Now you see from east to west in a Pacific, in a Atlantic Ocean, in Indian Ocean, you can see these currents in those three oceanic regions. And this one is the north equatorial current. There it is, north equatorial current, and here it is south equatorial current. Here it is south equatorial current. Okay, so the north or the south equatorial currents originates by the rotation of the earth. You can see it is found in all oceans. Have you got the idea about the Coriolis force, Bradul Raj? So Coriolis force is originated by the rotation of the earth, and it is maximum at which place? So maximum at poles. Maximum at poles, and it is 0 at equator. 0 at equator, and I think the direction of winds depends on the Coriolis force also. And also the direction of oceanic currents is also affected by the Coriolis force. You can see here. Okay, we have mentioned the primary forces that influence the currents are the Coriolis force, the gravity, the winds, and the heating by solar energy. Okay. So now we have understand what we have explained here. How the north and south equatorial current moves from east to west, because the earth is moving from west to east. Now we are coming for the next concept, how the prevailing winds generates currents. So let's see. Here we are seeing a current is moving from this side to that way, and at this place another current is moving. So when these two currents meeting at a place, it will raise the sea level here. Now you see it will raise the sea level because of the agglomeration of oceanic water here. Both will brought down what? The water, and the maximum water will agglomerated here, and now you see a prevailing winds is blowing above this region. Prevailing winds. Now you see the prevailing winds is blowing above this region, and these are the namely westerlies. We have discussed earlier in class westerlies winds. So the westerlies winds blows above this region where the sea level has raised. Because of the agglomeration of maximum water brought by these two currents. This is current 1 and here it is current 2. So when these two currents brought down the maximum water or mixes their water at a place, it will raise the sea level there, and because of the westerlies winds blowing above that surface of ocean, due to the friction, now you see, due to friction, a new currents will formed here. And the new currents will formed here, and it is called the drift. These are called the drift. Why it is called the drift? Because of the low velocity, and it is depends on the direction of winds. So it is so called the drift, having low velocity and depends on direction of winds. So earlier we have discussed the current having a low speed with direction, but this having a no direction. It is affected by the winds. When winds comes down by the shifting of pressure belts, these currents will also move down. Okay, because it is directed by the westerlies winds. Okay, because it is directed by the westerlies winds. So what about the difference between the current and the drift? So current having a direction as well as the speed, but this one having a very low speed with no direction, because it depends on the direction of winds. So ध्यान रखिएगा, no direction. These drifts having their not on direction, it will be changes with the changes of place of winds. Okay, is it clear? Are you getting me or not? Mradul, Aman. Next one is how a shape of coastal line can generate the oceanic currents at a local level. Okay. So next we are coming for the shape of coastal line. Here we have discussed about the prevailing winds. Here we have discussed about the prevailing winds. Here we have discussed about the rotation of the earth. And now we are coming for the shape of coastal line. Shape of coastal line. Okay. Where is remote? Oh, there is no need. It has started. Shape of coastal line, like see, the two conditions are I am showing here. The first one like this kind of shape, another like this kind of shape. There it is, the shape of coastal line. In Hindi it is called the तटीय क्षेत्र की आकृति. So, like you see that these are the coastal area, and a current is coming towards this region. When this current reach to that point, it will be bifurcated and divided into two currents. So you can see the one current divides into two currents. By bifurcation happens at this juncture because of the shape of coastal line. So at this part, the one current divides into two currents. So here it is, you can see the bifurcation of oceanic currents. Bifurcation of ocean current divides into two currents. So here it is the current 1 and here it is the current 2. So the currents also originated by the shape of coastal line. Okay, Chandan Kumar Rathore, very, very warm welcome, brother. At this channel, we are bound to deliver our classes in English because it is totally oriented for the Exampur IAS English medium. So we are trying our best to explain all content in English. Hope you all are getting our content. The most important thing is the concept. What I am delivering, it should be reached to your mind. How the origin of ocean currents happens. Okay, so I have just explained how the differences of temperature, salinity and density of oceanic water creates the ocean's current, how it is affected by the rotation of the earth, by the prevailing winds and the shape of coastal line. So hope you have got it. So now we are moving ahead. Okay. One question is for you. In 2015 questions. And now we are going to explain you about the anti-equatorial current also. How the anti-equatorial current flows and also the downstream is there. The two more phenomena I am going to explain. So first question here, the what explains the eastward flow of the equatorial counter current? Eastward flow of the equatorial counter current. So I have just explained the equatorial currents, but the question demands in what explains the eastward flow of the equatorial counter currents. What do you mean about the counter currents? Let's see. Like this is equatorial region. Now you're seeing current is coming this way. This one is north equatorial current and this side is south equatorial current. Here it is south equatorial current. When these two currents comes at this place, it will raise down the sea level at this zone. It will raise down the sea level at this zone. And this side is lower sea level, this side is higher sea level. Now it becomes the sea level higher at this zone and sea level lower at this zone. And so you can see these are the zone of doldrum. The occurrence of the belt of calm near the equator, that is the doldrum. That is the doldrum. There is not a horizontal winds blowing at this region. There is a lack of trade winds are there. So you can see the counter equatorial currents flows in between these two equatorial currents. And it's happened just because of the raise of the sea level. And this side, the lower the sea level, this side, the higher the sea level, and there is lack of horizontal winds are also there. And so the currents flows from this side to that way. And this one is called the anti-equatorial current. Anti-equatorial current or a counter-equatorial current. Or a counter-equatorial current. Is it clear, Chandan, Mradul, Aman? How the counter-equatorial current forms is just because there is a maximum agglomeration of water at this side because of the north or south equatorial currents and because of the lack of horizontal winds, because due to the doldrum region or a calm zone, the movement of oceanic water from this side to that way creates the anti-equatorial current or a counter-equatorial current. So here it is the question, and the answer is occurrence of the belt of calm near the equator. The question demands the earth rotation on its axis. Totally wrong, because the earth rotates from east to west, west to east, and it is also flowing from west to east. Convergence of the two equatorial currents. So that is not the only features, the convergence of the two equatorial currents will generate it. Okay. Difference in salinity of water. Okay, difference in salinity of water. So it is not only the impact. The impact is the convergence of oceanic, these two currents here. That is the good point. But it will raise the sea level at this juncture. And then you can see, just because of the differences of sea level, the water moves from this side to that way. And that is in between the north and the south equatorial currents. So you can see in whole oceanic region, in a Pacific or Atlantic or a Indian Ocean, you can see the anti-equatorial current or a counter-equatorial currents found between the north or a south equatorial current. North or a south equatorial currents. Okay. Is it clear? Radul, now have you got it or not? How the equatorial currents generates in this region, in between the north and the south equatorial current. Okay. So that is what we have explained, the origin of currents. And also, you see, one more diagram I am going to explain here. Like, see, this is oceanic region. This is oceanic region. I have just given the ideas how the origin of currents happens at this region. So, I am going to explain one more thing about it, and that is the one current moves above the oceanic surface and one moves in the beneath of that place also. So let's see. You see at this side the currents flows from this way to that way. Okay, it reaches to that place. Here you can see the density increases. When the density increases, it will go downwards, downwelling in here, and then there is another current beneath that surface region. Okay, and then at this place you see here it is upwelling process. So this side is upwelling process, and here it is downwelling process. Downwelling process. It happens because of the differences of density. Okay, because of the differences of density. So now you can see here it is the current, surface current, and this side is down current. This side is down current. Is it clear? So this is the underwater current basically. And here it is the downwelling process in which you can see the water moves downwards, and here you can see by the upwelling process the water moves upwards. So at the upwelling process, the cold water is coming to the surface and it will burn down the nutrients also. And at the several places of the world where the upwelling process are happening, that is the richest fishing ground is also. These are the richest fishing ground also. Richest fishing ground because the cold water will burn down the nutrients from the beneath of that place. Okay. Now it is clear. The downstream or upstream. These are the surface current. Here is the down currents which flows just above the plains region. Okay. Now we are going to have currents of Atlantic Ocean. Now we are going to discuss currents of Atlantic Ocean. Firstly, we will get the point about what are the currents which flows in Atlantic Ocean. Then we will show the guide made up by these different nature of currents, and then also we will discuss about the Gulf Stream, about the North Atlantic Drift, how the western coast of European continent gets warm all of the year, and it is so called the blanket of Europe. Which current is so called the blanket of Europe? Okay, so first of all get the name of the currents, and the first one here it is the cold current. This side is the cold current. This side is cold current. The first one is the Labrador current. Second one is Canary current. Third one is Benguela current. And the fourth one is Falkland current. Fourth one is Falkland current. Okay. Falkland current. Then you see here you can firstly mention the north and south equatorial current. North and south equatorial current. Then you see the Antilles current. Now you see the Florida current. Then the Gulf Stream. There is Gulf Stream. Next, North Atlantic Drift. Next one is North Atlantic Drift, having a three types. The first one is Irminger current. Second one is Norwegian current. And the third one is Rennell current. Third one is Rennell current. And the last current is found in Atlantic Ocean, that is the Brazil current. So these are the warm and the cold currents found in the Atlantic Ocean. Okay. Is it clear right now? Now we will discuss where it flows, what about their impact, what about the special features created by these currents. Okay. So firstly, write down these currents, and the most important is here. Labrador is the coldest current amongst the others. Okay, coldest current is this. And the Gulf Stream is warmest or hottest current. This one is warmest or hottest current. We are just going to discuss about the Gulf Stream. Okay. Is it clear? Now have a look of the North Atlantic current. The first of all. Here we are seeing North Atlantic current. Firstly, you see here the North Equatorial currents originates from the eastern side of Atlantic Ocean it flows to the western side of Atlantic Ocean nearby to the equator line. So you can see the North Equatorial current. Beneath it, the South Equatorial current, or in between these two, the counter equatorial current is also present. Okay. So when these winds, these currents coming to this side, okay. So here you can see the Antilles current. Now you are seeing what? The Antilles current is there. Okay. Antilles current is there. Bifurcated into two parts. One is also here. Now in the Gulf of Mexico, this side is the Gulf of Mexico. Here it is Gulf of Mexico. And from Gulf of Mexico, the Florida currents is moving to this place. And now you are seeing these two currents, these two warm currents meets at Cape Hatteras. Here it is Cape Hatteras. Cape Hatteras of USA, a new stream will generate. So these two currents meets at this place and creates a warmest or hottest current of the world. And that is the Gulf Stream. It is the Gulf Stream. It flows to the eastern coast of USA. And now it is reaching to the Newfoundland region. Now it is reaching to Newfoundland region. There is the Grand Banks region, the richest fishing ground of the world. Richest fishing ground of the world, where the maximum production of fishing are there. Okay, now you see the Labrador current is this part and the Gulf Stream is coming to this way. And because of these warm and cold currents, I will explain it later, it generates the advection fog, and there is a plenty of phytoplanktons will generate. There is a maximum production of fishes, and then you can see the maximum fisheries are happening there. Okay, and you see the Labrador currents and the Gulf Stream meeting at this region, it will raise the sea level, and because of the westerlies winds, there is a generation of another current, that is so called the North Atlantic drift. North Atlantic drift. And when it is going further, it divided into three currents. So one is Irminger currents. Now you can see the Irminger currents. Another one is Norwegian currents, and the third one is Rennell currents. Okay, here you can see the Rennell currents, and then lastly here it is the Canary currents, just at the coastal region of the western coast of the Africa. Western coast of the Africa. Here it is, you can see the Rennell. At this side is Irminger. And you can see the East Greenland current is also coming to this place, and the Labrador current is coming to this place. This is the largest fishing ground of the world. Largest fishing ground of the world is this. So now we can see here it is the 0-degree equator line, and the north equatorial current is this. This one is warm. North equatorial currents. Then it moves to Antilles, and then here it is the Florida. Now you see the Florida. Here it is Antilles. Then both of this current makes the Gulf Stream. So here it is the Gulf Stream. Now you see the Gulf Stream is there, and also there is coming a Labrador current. This one is Labrador, and because of the merging of these two currents, there is formation of another one, that's the North Atlantic Drift. North Atlantic Drift, and it divides into three regions. The one is Irminger, another one is Norwegian, and the third one is Renal. And then you see the another cold current is this, that is the Canary. So Canary, and this one is the Labrador. So now you see the two cold currents is there, also the East Greenland current is there. Okay, this will becomes a gyre. The circulation of oceanic water is called the gyre. Here you can show the circulation of oceanic water. What is it? The gyre. What is it? Gyre. And in the northern hemisphere, in Atlantic Ocean, you see there is clockwise direction of this gyre. There is clockwise direction of this gyre. So now you can see the clockwise direction. Clockwise direction. In North Atlantic Ocean. Clockwise direction in North Atlantic Ocean. In most probably in 2019 or 2018, one questions in UPSC IAS has arise from this figure about the gyre of the North Atlantic Ocean. Okay. Now we are coming for the Gulf Stream and the concept of North Atlantic Drift. And also, I will show you the currents of South Hemisphere also. See here. This is the currents of South Hemisphere. See. So there it is the North Equatorial current, and in between the North and the South there is a counter equatorial current is there. Again you see the equatorial current is coming to this way. The bifurcation of this current, and the one is Antilles, other one is Brazil. So this side you can see here it is the Brazil current, and this side is the Antilles current. Okay, and also you see the Brazil currents meeting with the Falkland current, which is the cold current. This side is also cold current. So at this place or a meeting place of the nearby the Argentina, this is the region of Argentina. It creates also a richest fishing ground here. This side is also richest fishing ground or a rich fishing ground? Because of the merging of cold and the warm water. Because of the merging of cold and the warm water. And now you see, nearby the Antarctica, there is a west wind drift. And it flows because of the westerlies winds. It flows because of the westerlies winds, like the North Atlantic drift was formed as it is. The west wind drift was formed by the impact of westerlies winds. Okay. By the impact of westerlies winds. And now you can see here, there is the Benguela current. Benguela current is a cold current. It flows nearby to the Namibia. There is a hot desert, Namib desert, and just close to the Kalahari desert. Okay. So in southern hemisphere, you see the direction or circulation of oceanic water is in a counterclockwise. Okay. So circulation of water is gyre. If you talk about the gyre, it would be counterclockwise. Is it clear? So in the northern hemisphere, the gyre direction is the clockwise, and in the southern hemisphere, the gyre direction is the anti-clockwise or a counterclockwise. Anti-clockwise or counterclockwise. Okay. So now we are moving for the concept of Sargasso Sea, North Atlantic drift, and the Gulf Stream. Okay. So now we are going to have some information about this place. Near the Grand Banks, the Gulf Stream mixes with cold Labrador and East Greenland currents and flows eastward across the Atlantic as the North Atlantic drift due to the impact of westerlies winds. Due to impact of westerlies. Okay. Then here westerly movement of North Atlantic drift is due to the influence of westerlies. अच्छा ये तो लिख ही दिया, तो इसको लिखने की जरूरत नहीं है. जो whatever I have explained, that is the main concept, and you should have to remember all concept given by me. Not a single concept you should have to left. Otherwise, the questions, the demands of question can't be fulfilled by from your side. Okay. So here we are saying the Gulf Stream mixes with cold Labrador and East Greenland currents and flows eastward across the Atlantic as the North Atlantic drift. Here westerly movement of North Atlantic drift is due to the influence of westerlies winds, or simply westerlies. Now you see the picture. You can see here the Newfoundland region is this. It comes into Canada. Newfoundland region, it is in Canada. Here it is in Nova Scotia, Quebec, and the Labrador region. And the Labrador current is coming from the polar region. Labrador current is coming from polar region. This is the coldest current ever. This is coldest current. Okay, and this side the Gulf stream is coming from Cape Hatteras, and it generates because of the mixes of the Florida and the Antilles. So when these two mixes at these places, that is the region of Grand Banks. This is the region of Grand Banks, the richest fishing ground of the world. What is it? The richest fishing ground of the world. How it happens? So let's see. From this side, cold current is coming, and this side the warm current is coming. When these two meets at this place, because of the different heat of these two currents, here the advection fog will form. Now you see the advection fog will form at this place firstly, and due to this the Titanic Jahaz was sinked into Atlantic Ocean almost in 1913 or something around. Okay, so why Titanic was sinked down? Because of the less visibility, and less visibility creates by the advection fog. So it will create the advection fog there and the maximum development of planktons. Maximum development of planktons. And because the planktons is the food of the fishes, and so the maximum production of fishes here. Now we are seeing maximum production of fishes. Maximum production of fishes, and when the maximum production of fishes are there, when you drop the क्या बोलते हैं जाल, okay, so what will happen? We can catch the maximum fishes, and so what? This will become the maximum fisheries of the world. This is the zone where the maximum fisheries of the world. So this zone is Grand Banks. This is Grand Banks, nearby Newfoundland, Canada. Nearby Newfoundland, Canada and USA. So here it is the Labrador, and this side is the Gulf Stream. Okay, have some more point about the Gulf Stream. Have some more point about the Gulf Stream. Gulf Stream was discovered by Ponce de Leon. Ponce de Leon, and it generates nearby the Cape Hatteras, what I have said. Okay, it generates at the Cape Hatteras, and there you can see the Labrador current. The one part of Labrador current is going to or moving to this place, and this will create a cold wall. This will create a cold wall here. Okay, this is creates a cold wall here. So sometimes the question also demands the eastern coast of USA is not totally covered by snow in the winter season. Because of what? So because of presence of Gulf Stream currents in the eastern coast of USA. Okay, in the eastern coast of USA. Right. So is it clear? Is it clear, Mradul? So there is also a cold wall. You can see in between the coastal region and the Gulf Stream region. So the one part of the Labrador current is moving to this side, and it is create a cold wall. Okay. Then, so Gulf Stream was discovered by the Ponce de Leon, and also I have explained how the eastern coastal region of the USA haven't totally snow-covered regions becomes a snow-covered regions in winter season. Okay, in winter season. Okay, next. Like you see, some more point about this. Grand Banks, richest fishing grounds on Earth. The two cold currents, the East Greenland current and the Labrador current, flow from the Arctic Ocean into the Atlantic Ocean. Flow from the Arctic Ocean into the Atlantic Ocean. The Labrador current flows along part of the east coast of Canada and meets the warm Gulf Stream. What I have explained, that is written in this slide also. The confluence of these two currents, one hot and the other cold, produce the famous fogs around the Newfoundland. As a result of mixing of cold and warm water, one of the world's most important fishing ground is created. Getting a point? What I have explained, that is written also in slides. Next, seawater needs to be mixed regularly to bring the nutrient-rich deep waters up to the sunlight zone where the phytoplanktons can grow. That is the most important point, what I have explained earlier. If the upwelling process is happening, when the upwelling process is happening, it will brings down the nutrients of the lower region of this place. Now the nutrients is coming to this place, and because of the sunlight, the maximum production of phytoplankton, it will create the maximum growth of phytoplanktons. Maximum growth of phytoplanktons. Maximum growth of phytoplanktons. Okay. Okay. And the upwelling, it also happens in nearby to the Peru coast or the Chile coast. Okay. So the upwelling near the Peruvian coast are very productive. So the upwelling process happens in the oceanic region. In this process, you see the nutrients of the lower region comes to the surface areas, and because of the sunlight is there, the maximum growth of phytoplanktons happening. Okay. Now we are coming for a Sargasso Sea. What you know about the Sargasso Sea? Sargasso Sea. Have a look first of all. In this picture we are seeing here, that is the guide and the circulation of oceanic water. But this side, see here, this is a place where there is a lack of circulation of water. Lack of circulation of water is happening here. And this is the Sargasso Sea. Here it is the Sargasso Sea. Okay. Now we are getting some knowledge about the Sargasso Sea. First of all, a sea without a land boundary. Question has already arisen from this point. Sargasso Sea don't having a land boundary region, and it is not an actual movement of a water is happening there. It is totally looks like a lake or a jheel. The Sargasso Sea is a region in the gyre in the middle of the North Atlantic Ocean. It is the only sea on earth which has no coastline. What I said? Which has no coastline, and there is not a single oceanic currents are flowing in that region. Okay, not a single oceanic currents is flowing in that region. So it is bounded on the, it has asked in the UPSC IAS exam, It is bounded on the west by the Gulf Stream, north by the North Atlantic Current, east by the Canary Current, and the south by the North Atlantic Equatorial Current. Okay. So Sargasso Sea is found in Atlantic Ocean. It is nearby to the 30 to 40 degree north latitude. Area is 30 to 40 degree north latitude. Salinity is high at this region. Salinity is high. And the seaweeds, now you see in this region, the system of ocean currents from the North Atlantic Gyre, all the currents deposit the marine plants they carry into this sea. Okay, this is the reason Sargasso Sea. Okay, this is the reason Sargasso Sea. So there is a currents or circulation of currents in this region. Circulation of currents. Okay, this is the reason of Sargasso Sea. Some more points about the Sargasso Sea. It is calm and a stable zone. Sargassum grass or seaweed grows there. Richest in fishing ground. Rich fishing ground. Okay, and it is found at the eastern coast of USA. Found eastern coast of USA. This one is the North America, and it is found eastern coast of USA. Okay. Yeah, exactly, Mradul. Sargasso Sea having a good fishing region. Exactly. I have just mentioned it. The rich fishing ground. Okay. So areas around the 30 degree to 40 degree north latitude, and the salinity is high because of the calm and a stable zone. Sargassum grass or a seaweed grows there. Sargasso name given upon the Sargassum grass is found there. That is the seaweed. Okay. Is it clear about the Sargasso Sea? Now we are going to discuss the North Atlantic Drift. The North Atlantic Drift. Let's see. There is a warm current, Gulf Stream. And there is cold current, Labrador. Or because of the impact of westerlies winds. Westerlies winds, a new current has formed. That is the North Atlantic Drift. North Atlantic Drift. And let's see, it has divided into three current. North Atlantic drift divided into three current. This is Greenland, this is Iceland. Greenland, and this one is Iceland. This is London, England, United Kingdom, and here it is the Norway. This side is the Norway, and here it is Kola Peninsula, Russia. Kola Peninsula, Russia, and there is Murmansk. Murmansk, northernmost port of the world, open for trade throughout the year. Open for trade throughout the year. Density will increase, Mradul, there because of the salinity is high. There is lack of ocean currents are there. At Sargasso Sea, there is no oceanic current. Okay. At Sargasso Sea, no oceanic current. Also remember, at Sargasso Sea, no ocean current. In Sargasso. Okay. So here we are seeing the Irminger, Norwegian, and the Rennell. The three currents of North Atlantic drift. The three currents of North Atlantic drifts, and these warm winds will warm the western coast of European countries throughout the year. And that's why the North Atlantic drift I am mentioning in next slide. North Atlantic drift is called blanket of Europe. Okay, blanket of Europe. And then one more, northernmost port of North Pole is open for trade throughout the year due to presence of North Atlantic drift or Norwegian current. Or Norwegian current. Is it clear, Mradul? Okay. I have a scheduled event at 12:50 p.m. on a Bihar exams for Exampur also. That's why I'm watching there. No issue. We have some 20 minutes left. So we are going to discuss some more concept. Oh, okay. One more thing I want to explain here. That is, like you see in a current, in a drift, in a stream. What about the difference between these three? What about the difference between these three? So you see the current, drift, and a stream. So current is having a speed as well as the motion as well as the direction. So there is a speed. It would be low speed and direction. It attains a directions. What about drift? Low speed because it is influenced by the westerlies or trade winds. Low speed, no direction. No direction. And in a stream, you see the high speed and direction, both. And it flows like a reverse. It flows like a reverse. That's the stream. Okay. So that is all about the North or South Atlantic Ocean current. Now we are moving to Pacific Ocean current. Now we are moving to Pacific Ocean currents. Currents of Pacific Ocean. Currents of Pacific Ocean. So firstly write down the current's name. It is the cold current and the warm current. Cold current, namely the Oshio, is also called the Okhotsk, and it is also called the Kurile. And then you see California. Then you see the Peru or Humboldt, and the La Nina, the exceptional. La Nina, exceptional. Now we are coming for the hot current or a warm current. The first one is Kuroshio. Kuroshio, called the black current, Japan. Nearby the Philippines, called black current, Kuroshio. Then you see the Tsushima, nearby Japan coast. Nearby Japan coast. Then Alaska. Then East Australian current. So these are the currents of Pacific Ocean. Again, in the northern Pacific Ocean, there is a circulation of water that makes a gyre of the clockwise direction, and the southern hemisphere it creates a anti-clockwise or a counterclockwise direction. Okay, let's have a look. Here you are seeing. So again you are seeing here the north equatorial currents and the south equatorial currents, and in between these middle of the region counter equatorial current is present. So it comes to this side and then moving as a Kuroshima currents. Here the Okhotsk or Oyoshima currents are coming, and this is the also richest fishing ground of the world, of the Japan and the China. And then you see the North Pacific currents and the Alaska current and the California current. California is the cold current, so this is present in the blue. Okay, and you can see the East Australian current and the South Pacific current, that is the west wind drift basically, and the Peru or a Humboldt current is this. So these are the currents which is found in the Pacific Ocean. Okay, which is found in the Pacific Ocean. Okay. Next we are coming for the Indian Ocean currents. Currents of Indian Ocean. Currents of Indian Ocean, namely, again it is the cold current and the warm currents. So the cold current is a West Australian current, which is present throughout the year, and the exceptional Somali current is also formed. Somali current is also formed in the eastern coast of Africa. This side, the warm current is there. And this is the Agul Has current. Then you see the Mozambique current. And the Malagasy current. Actually, this channel is new, but the content or the teachers are there. That is awesome, no doubt. We are providing very nice content here, nice concept here at this channel. The students are not actually aware about this channel. Later on, through the more publicity, they will know. So these are the warm and the cold current of Indian Ocean. Now you see in Indian Ocean currents, Indian Ocean is half an ocean. Hence, the behavior of the North Indian Ocean currents is different from that of the Atlantic Ocean currents and the Pacific Ocean currents. So, this is the only one ocean where the reversal of oceanic current is happening. Let's have a look. Also, monsoon winds in northern India oceans are peculiar to the region which directly influence the ocean surface water movement, North Indian Ocean currents. Okay. Next, we are seeing Indian Ocean currents and monsoons. How these two correlate. Indian Ocean currents and monsoon. Just because of the monsoonal winds are seasonal. In summer, it blows from southwest direction, and in winter, it blows from northeast direction. And so the oceanic water acquires the direction of these winds because of the impact, because of the frictions happens by these winds. So now you see the currents in the northern portion of the Indian Ocean change their direction from season to season in response to the seasonal rhythm of the monsoons. What I said? The seasonal rhythm of the monsoon, the Indian Ocean currents change their direction from season to season. In summer season, it would be the southwest monsoon. In winter season, it requires the northeast monsoon or northeast direction. So the effect of winds is comparatively more pronounced in the Indian Ocean. Getting the point? Indian Ocean. Now you see here the currents of the Indian Ocean in winter. The first of all, we are going to see the currents of the Indian Ocean in winter. So there is a north equatorial current. In the winter season, you can see the counter equatorial current is also present in Indian Ocean. But in the summer season, you will see the lapse of or the lack of counter equatorial current. Or that would be lapse. So north equatorial current flows to this way from east to west and then moves to this way. Okay. From northeast to southwest direction. So there the direction is like this. Okay. Like this. So this is direction. In winter season, it acquires the anti-clockwise direction in northern hemisphere. Or in the southern hemisphere, it remains same for the both seasons. So in southern hemisphere, you see the east to west flows of oceanic currents. So there is the Mozambique, here it is the Malagasy and the Agulhas current. Agulhas current. So Mozambique, Malagasy, Mozambique, this one is the Mozambique, here it is the Malagasy, and when these two forms, then the Agulhas current is formed. And then the west wind drift is there. And here it is seeing the west Australian current. And so the completion of gyre in the southern hemisphere. So in southern hemisphere, the gyre has completed and remain same anti-clockwise direction, not a counter-clockwise direction. But in the northern hemisphere, you see the changes of oceanic currents directions because of the monsoonal winds. Because of the monsoonal winds. So just you have seen the winter and now you see the impact of monsoon or a summer season. So in summer circulation, you are seeing the north equatorial current and the counter equatorial current are absent. So in summer circulation or summer season, you are seeing the north equatorial current and the counter equatorial current are totally absent in northern hemisphere, Indian Oceanic region. Why Indian Ocean current changes according to the season? Because of the wind's direction. Because of the winds, frictions happens by the winds which blows above the oceanic surface. Okay, Mradul. So in summer, you're seeing that due to the effects of the strong southwest monsoon, what you have asked, I have mentioned it earlier. In summer, due to the effects of the strong southwest monsoon and the absence of the northeast trades, a strong current flow from west to east because of the frictions happens above the oceanic surface. Okay, which completely obliterates the north equatorial currents. Totally obliterates the north equatorial current. Hence, there is no counter equatorial current as well. So, there is the absence of north equatorial current and the counter equatorial current. Because the winds having a direction of the southwest. So, in the northern hemisphere, the oceanic currents is also flowing from southwest to northeast. Because of the frictions happens by the winds. Okay. Then you see, thus the circulation of water in the northern part of the ocean is clockwise during this season. So, in summer season, the circulation of oceanic water having a clockwise. But in a winter season, it requires the anti-clockwise, which I have also just explained. Shivam Pandey. Shivam Pandey, now I am also present on the English medium channel, that's the Exampur IAS, or I'm trying my best to explain the whole content in English My content are awesome here. If anyone watched my content that is totally free on YouTube, they will get the knowledge what is happening on this channel. Okay. Okay. So next we are coming for, here you are seeing the absent of north equatorial current and the absent of south equatorial current. Because the winds blows from southwest to northeast, so the oceanic currents is also flows from southwest to northeast, but in some in southern hemisphere it remain same. Southern hemisphere it remains same. Only changes happening in northern hemisphere. So the currents of the Indian Ocean in summer, you can see, have changed their direction. So the Indian Ocean is the only ocean which having a changes of oceanic currents direction. Okay. Shivam Pandey, Monday, Tuesday, Wednesday, my class scheduled at this channel from 11 to 1 p.m. I have completed several parts of the climatology and now I am finishing the ocean currents. Earlier I have finished the ocean relief here. So you can watch my videos, you can share or like if you like my videos. Okay. So today we have to stop our class right now because of my event has scheduled already on a 12:50 p.m. at Bihar exams by Exampur. So I have to stop my class right now. We will meet on next Monday 11 a.m. morning, and then we will continue with how the hot deserts has formed on the western side of continent. Okay, and several the main questions are there. I have brought down for you. Okay, so watch my whole videos. You will like it definitely. I have given the awesome content with the such a nice explanation. I'm trying my best to explain all things in English. If you are from English medium, you have to thoughts. You have to think in English. You have to write in English. You have to speak in English. So as well as I am also concerning on this. ओके शुरुआत कहीं ना कहीं से तो करनी है सो मेरे से ही सही सो मिलते हैं नेक्स्ट क्लास में टिल देन खुश रहिए मस्त रहिए नेक्स्ट क्लास में मिलते हैं थैंक यू